Hello guys, welcome back to another video on my channel. Today we have this challenge before us, and it is the square root of I. I'm sure before now it's most likely you've heard about I, and that you are also it is also possible you must have heard that I is the square root of -1. Okay, so if that is the case, have you thought about finding the square root of I itself? And can we ask ourselves the question, is the square root of I real or complex number? Okay? Well, the truth is that the square root of I is actually a complex number. Alright, in fact, a set of two complex numbers. And that is what we are here to prove. That the square root of I is a set of two complex numbers. And so, if you are ready, let's get started. Solution. Now, in my introduction, I said that the square root of I is a complex number. So what about we represent square root of I as a plus bi, which we all know to be a complex number. And therefore, we can say that if we take the square of both sides, this would be a plus bi squared. Alright? And then, if the square and the square root on the left hand side cancels out each other, so we're going to have it that I equal to a plus bi squared. And don't forget that from algebra, a plus b squared is the same thing as a squared plus 2ab plus b squared. Now I'm going to use this identity to expand what we have on the right hand side, and therefore I will simply give me a squared plus 2abi plus bi squared. Taking it further from here, you can say that I equal to a squared plus 2abi plus b squared I squared. Now we know that if I is square root of -1, then it means that I squared will be square root of -1 squared, which will give us -1. So meaning that here we are going to represent I squared by -1, and so I give me a squared plus 2abi. So now you have plus b squared times -1, and so we have I is equal to a squared plus 2abi minus b squared. So at this juncture, I'm going to take the real parts together. So I have I squared equal to I will be equal to a squared minus b squared plus 2abi. Now, since we can see that on the right hand side we have the real part and then the imaginary part. Here on the left we only have the imaginary part. So what do? Let me do justice to what we have on the left. So what I do justice to do is to introduce, since there is no real part, I can represent that as 0 plus, and then I introduce 1i. Okay, so that on the right now we have a squared minus b squared plus 2abi. I can also square this and put a plus, not square, put a bracket around it, and then I introduce the plus. So we can now make a comparison between the right side and then the left hand side. So once we do that, what we'll get is that we have it at a squared minus b squared equal to 0, call that equation 1, and then 2ab will be equal to 1. I call this equation 2. So what we now need to do is to find both a and b. So once we get our a and b, we can now take that, the value of a and b, and plug them back into the into this equation, since we know the value of a and b. So that will give us the value of the square root of I. So let's come back here from equation. Let's start with equation 1. From equation 1. From equation 1, we have it that a squared minus b squared equal to 0. So that means that a squared will be equal to b squared. So if a squared equals to b squared, what that means is that a will simply be equal to b. So if a squared equals to b squared, then we have it that a will be equal to b. Let's call this equation 3. Now let's go back to equation 2. From equation 2, we have it that 2ab equal to 1. So this means that if I divide both sides by 2a, that is, I'm interested in making b the square of formula, so I divide both sides by 2a. So a and a will cancel out, 2 and 2 will cancel out, so b will be equal to 1 over 2a. Now if I take this back into equation 2, so put b equal to 1 over 2a into equation 3 rather, into equation 3. So what I'm going to have is that a will be equal to 1 over 2a. So now if a equal to 1 over 2a, that means that multiplying both sides by 2a, I'm going to get 2a squared equal to 1. So if 2a squared equal to 1, it then means that what that means is that a squared will be equal to 1 over 2, meaning that a will be equal to plus or minus square root of 1 over 2. And then if I go ahead and rationalize this, we have a will be equal to plus or minus square root of 1 over square root of 2, which is the same thing as plus or minus 1 over root 2, which, like I said, if I go ahead and rationalize the denominator, a will give me square root of 2 over 2. So what that means is that a equal to root 2 over 2, and a is also equal to minus root 2 over 2. Now, having obtained the value, two values for a, can we go ahead now and find the corresponding values of b? The answer is yes. So what I just need to do is to go back to equation 1, where we have, okay, I think just go back to equation 1. So from equation 1, where we have a squared minus b squared equal to 0. So a squared will be equal to b squared, and so a will be equal to b. So now let's take the first value of a. If a equal to root 2 over 2, for a equal to root 2 over 2, then b will be also will be root 2 over 2. Root 2 over 2. For a equal to minus root 2 over 2, then we have it that b also will be equal to minus root 2 over 2. So what that means is that for I, the square root of I, we are going to get two values, which will be plus and minus. Yes, if we take these two values together, so this will be, for this we have this, for A, if A is minus root 2 over 2, then B is also equal to minus root 2 over 2. So meaning that we can actually combine the two results, and that will give us the square root of I to be plus or minus root 2 over 2 plus root 2 over 2. So guys, there you have it. We've been able to prove that the square root of I is a set of complex numbers. So guys, do not forget to subscribe. If you are coming across my channel for the first time, please also like my video, share the video so that others can also learn, and that the YouTube algorithm will push the content more to others. So I'll see you in my next video, where I bring to you another very interesting problem. Thank you, and I'll see you.